My name is Nur Amira Safia binti Muniriza. S63095 are going to present an individual presentation about initial IMO strategy on reduction of GHG emission from ships. GHGs are gases that trap heat or long-wave radiation in the atmosphere. Carbon dioxide, methane, nitrous oxide, and fluorinated gases are the most important GHGs. GHGs can be 1,000 times more powerful than carbon dioxide and remain in the air for thousands of years. What causes GHG emission? GHG emission from transportation primarily come from burning fossil fuels for our car, truck, ships, train, and planes. Over 90% of the fuel used for transportation is petroleum-based, which include primarily gasoline and diesel. How does it happen? So the direct emission are produced by burning fuel for power or heat through chemical reaction and from leak from industrial process or equipment. Most direct emission come from the consumption of fossil fuels for energy. What role it plays in pollution or climate change? In terms of pollution, it involves air pollution. Gasoline used contribute to air pollution. Thick and highly flammable liquid, the vapor given off when gasoline evaporates, and the substances produced when gasoline is burned, which are carbon monoxide, nitrogen oxide, particulate matter, and unburned hydrocarbon, contribute to air pollution. In terms of climate change, as GHG emission from human activity increase, they build up in the atmosphere and warm the climate, leading to many other changes around the world, in the atmosphere, on land, and in the ocean. Vision. The initial GHG strategy of the IMO has three interconnected goals. International shipping's carbon intensity must be reduced by at least 40% by 2030 when compared to 2008. Following that, we will pursue effort to achieve a 70% reduction by 2050 in comparison to 2008. Finally, by 2050, reduce total annual GHG emission from international shipping by at least 50%. Existing and proposed amendments to the Pollution Prevention Treaty, MARPOL, take a technical and operational approach to reducing GHGs in order to provide a regulatory framework to achieve these targets. These are some examples. For the Energy Efficiency Design Index, EEDI, the energy efficiency ships must be built and designed. For the Ship Energy Efficiency Management Plan (SEEMP) is a useful tool for assisting ship owners in managing their environmental performance and increasing operational efficiency. For the Energy Efficiency Existing Ship Index, the EEXI, which is scheduled to go into effect in 2023, applies many of the same design standards as the EEDI, with some modification relating to restricted access to design data. The IMO is putting decarbonization measures into action in two phases, starting with a small number of short-term measures and moving on to more extensive medium and long-term measures. In 2023, the initial IMO GHG strategy will be updated. The initial IMO strategy on reduction of GHG emission from ships. IMO remains committed to reducing GHG emission from international shipping and, as a matter of urgency, aims to phase them out as soon as possible in this century. This is the vision in the initial strategy on reduction of GHG emission from ships, adopted in April 2018. The levels of ambition includes reduction of carbon dioxide emission per transport work in carbon intensity as an average across international shipping by at least 40% by 2030, pursuing effort towards 70% by 2050 compared to 2008. Next, for the first time, a reduction of the total annual GHG emission from international shipping by at least 50% in the 2050 compared to 2008, while at the same time pursuing efforts toward phasing them out as called for in the vision for achieving carbon dioxide emission reduction consistent with the Paris Agreement's goal. Level of ambition to achieve IMO 2050. This chart is an illustration of the overall GHG reduction pathway to achieve IMO's ambitious goal. For example, the absolute level of GHG emission reduction identified in the IMO GHG strategy, at least 50% reduction by 2050 expressed in the illustrative chart in solid color and green stripe. These are the timetable of IMO action to reduce GHG emission from ship. In year 1997, resolution on carbon dioxide emission from ship establishes IMO mandate on GHG emission control. In year 2003, resolution on IMO policies and practices related to the reduction of greenhouse gases emission from ship. In the year 2013, new regulatory tools to improve the energy efficiency of international ships. For example, mandatory design requirement EEDI for new ship, which set increasingly strict carbon intensity standard, and mandatory ship energy efficiency management plan SEEMP for operators to improve the energy efficiency of all ships. In year 2015, EEDI phase 1, which is 10% reduction in carbon intensity of the ship. For the 2016 mandatory IMO data collection system, which is ships of 5,000 gross tonnage and above, 80% of emission from international shipping are required to collect fuel oil consumption data for annual reporting to IMO from 1st January 2019. For the year 2018, resolution on the initial IMO strategy on reduction of GHG emission from ship, and in the year of 2019, adoption of a procedure to assess the impact on states of candidate measure, strengthening of the EEDI requirement for some ship types, resolution on ports and shipping cooperation, and establishment of a GHG Technical Cooperation Trust Fund within IMO. In the year 2020, EEDI Phase 2, up to 20% reduction in carbon intensity of the ship. In 2023, complete short-term measure and revise the initial strategy. For the 2025, EEDI Phase 3, up to 30% reduction in carbon intensity of the ship. For example, early entry into effect 2020 for several ship types with up to 15% carbon intensity reduction for largest container ship. For the 2023 until 2030, midterm measure to reduce carbon intensity of the fleet by at least 40%. By 2030 to 2050, long-term measure to reduce carbon intensity of the fleet by at least 70%. And in the year 2050, at least 50% reduction of total annual GHG emission, require approximately 85% carbon dioxide reduction per ship. One important element of Kyoto Protocol was establishment of flexible market mechanism, which are based on the trade of emission permits. Under the protocol, countries must meet their targets primarily through national measure. However, the protocol also offers them an additional means to meet their targets by way of three market-based mechanisms. First one is international emission trading, second one the clean development mechanism, and the third one is joint implementation. This mechanism ideally encourages GHG abatement to start where it is the most cost-effective. For example, in the developing world, it does not matter where emissions are reduced as long as they are removed from the atmosphere. This has the parallel benefits of stimulating green investment in developing countries and including the private sector in this endeavor to cut and hold steady GHG emission at a safe level. It also makes leapfrogging, that is, the possibility of skipping the use of older, dirtier technology for newer, cleaner infrastructure and system with obvious longer-term benefits, which will be more economical. Monitoring emission target. The Kyoto Protocol also established a rigorous monitoring, review and verification system as well as a compliance system to ensure transparency and hold parties to account. Under the protocol, countries' actual emissions have to be monitored and precise record have to be kept of the trade carried out. A registry system track and record transaction by parties under the mechanism. The UN Climate Change Secretariat, based in Bonn, Germany, keeps an international transaction log to verify that transactions are consistent with the rules of the protocol. Reporting is done by parties by submitting annual emission, inventories, and national reports under the protocol at regular intervals. A compliance system ensures that parties are meeting their commitments and helps them to meet their commitment if they have problem doing so. For the adaptation, the Kyoto Protocol, like the convention, is also designed to assist countries in adapting to the adverse effect of the climate change. It facilitates the development and deployment of technology that can help increase resilience to the impacts of climate change. The Adaptation Fund was established to finance adaptation projects and program in developing countries that are parties to the Kyoto Protocol. In the first commitment period, the fund was financed mainly with a share of proceeds of CDM project activities. In Doha in 2012, it was decided that for the second commitment period, international emission trading and joint implementation will also provide the adaptation fund with a 2% share of proceeds. There are 3 examples of launch project. First is GHG Smart Project. GHG Smart Project is a project that assisting the least developed countries and small island developing state in their capacity building effort through training courses over a 4-year period. The program consists of the development of a training package, delivery of a series of 5-day training course using the training package over the next 4 years for the post-training monitoring, evaluation, and refinement of the overall training program, and lastly, program management and governance. For the Green Voyage 2050, explore various alternative fuels and energy carriers for the maritime sector, including those that are commercially available as well as currently under development. The workshop consider potential production pathways, emission reduction potential, infrastructure and onboard requirement, as well as implication on cost. The overall aim is to better understand some of the potential alternative fuels in the future marine fuel mix and assess opportunity and barrier of each option. For the Global Maritime Technology Cooperation Center Network, GMN, since their establishment in 2017, 4 Maritime Technology Cooperation Center (MTCCS) based in Africa, Asia, the Caribbean, and the Pacific have established strong regional network and are becoming important regional player with technical expertise in the field of maritime energy efficiency and greenhouse gases emission from shipping. In the first quarter of 2021, activities included regional maritime technology conferences and exhibition for the Caribbean and Africa, and MTCC Africa Sulfur Limit Implementation Workshop organized in collaboration with the World Maritime University WMU and Danish Maritime, and a regional ship technology conference organized by MTCC Asia. A key project to support the reduction of GHG emission from shipping in developing countries through Regional Maritime Technology Cooperation Center has been extended to March 2022. The Global MTCC Network GMN project is implemented by IMO and funded by the European Union to improve energy efficiency in the maritime sector by supporting developing region in the move toward maritime decarbonization. In the next few months, the GMN will deliver webinar for the Caribbean, organize industry-focused engagement in the Pacific, and develop and deliver a global webinar series on maritime technology barriers and opportunities. The center have undertaken a range of pilot projects, completed port energy audit, and established branch offices in 3 countries. This will allow this strategic project to continue its decarbonization pilot project and training and work towards financial sustainability in the longer term. The project has developed an online training program on maritime energy management and the implementation of MARPOL Annex 51 MTCC Caribbean. The MTCCs are also linked to other projects implemented by IMO to help drive forward the changes which are required to decarbonize shipping. During the COVID-19 pandemic, the MTCC have developed alternative plans and ensure continued engagement with stakeholders, including 10 events held during 2020. The pilot project ranged from data collection to install of solar power onto ferry in the Pacific. The MTCCS boosts resources to support local and regional partners. It is crucial to reduce the GHG emission from ships because they contribute to global warming. Global warming is brought on by greenhouse gases, which trap heat that would otherwise escape from the atmosphere. The consequences of greenhouse gases on the environment and the human health are extensive. By trapping heat, they contribute to climate change and respiratory disease brought on by smog and air pollution. Other repercussions of climate change brought on by greenhouse gases include extreme weather, interruption in the food supply, and an increase in wildfire. These gases can absorb radiation and hold onto heat, unlike oxygen and nitrogen. Shipping contributes to climate change by emitting black carbon particles, which are small black particles released during the combustion of marine fuel. Black carbon particles are mostly produced by ships burning heavy fuel oil. We need to reduce GHG emission in order for the next generation to live a better life.